Hello, and today I'm going to be doing the install for a Raspberry Pi Pico, otherwise known as an RP2040. So as you can see, I already have the Raspberry Pi Pico plugged in via USB. Now switch over to our virtual machine. You can see the Raspberry Pi Pico comes up as a USB device. And when you go into the USB device, it gives you two information files, that it's a UF2 bootloader, the model of the Raspberry Pi Pico, and then the board ID of the Raspberry Pi Pico. If you go to the index file and open that, it will redirect you to the Raspberry Pi website where all the install instructions are. Now, we can have an overview here, but mainly what I want to install is the C and C++ SDK. So I'm going to go over there. In the documentation, it will take you over here. Most of this can be ignored. It's intended for compiling on a Raspberry Pi itself or a Linux distribution. But we're on Windows, so we're going to go through a different set of steps. So we click on the Getting Started link over here. That will take us to a PDF with the install instructions. We can skip to the table of contents. For Linux installations or on a Raspberry Pi itself, you can just go to the SDK section. For Windows builds, you want to skip down to 9.2, which is building on MS Windows. Now you have two options for installing on Windows. You can use the Pi Pico installer, which is linked over here. And if we open that, it will take you to a Git repository. You can give it a read here. Here's the set of tools that it includes, and then if you want to download the installer, you go to releases, and for the current version is 151, and then you can just download your setup installer.exe here, which is 300 megabytes. I am going to do this a bit different. Building examples. Here we go. Alternative manual installation. So for a manual installation, it lists the tools you'll need. So it's going to be the ARM GNU toolchain, CMake, build tools for Windows 2022, Python 3.10, and then Git as well. So we'll start with the ARM toolchain. We'll work it from top down. So the current version of the ARM GNU toolchain is 13.2.rel1. So we just scroll down here and then you'll see the Windows release, which is MinGW64i blah blah blah, hosted cross toolchain, and we want the exe for that. We want the specific one that says ARM non-EABI, so that will download. Then we can go to the next one. We can get CMake, and for CMake we'll get the Windows 64 installer, so this MSI file. So these two are downloading. Then we get the build tools for Visual Studio. Okay, so that is the one we want. Okay, and then we want Python. And we want the 64-bit installer for Windows. And then finally we're going to get Git. And we want the 64-bit installer again, depending on your system, but 90% of people are on a 64-bit system, so you're going to most likely use that. Okay. So we're just waiting for the toolchain to download. As soon as the compiler's downloaded, we can continue. So while we wait, it says during the installation, we need to add the path to the Windows shell. Installing CMake. Again, we have to add it to the path. Installing builds, okay. Installing Python, installing Git, getting the SDK and examples. Okay, that's all fine and well. Okay, so we start with our compiler. I'm just launching it from the browser download tab. Just go English, next, agree. Okay, so a little trick here. I don't like spaces in my compile paths because that usually causes me issues. So I'm just going to put it in ARM in my C drive. And we are going to say this is going to erase that, and it's going to be ARM non-EMB. So this path. If you see there's also a space there. So I've generated the path now that has no spaces in it. And we just click install. Okay, now after it's done installing, we don't care about the README and we don't want to launch the bat file. We want to add path to environment variable. This is very important. Otherwise, you're going to have to add it manually and it's a pain in the butt. And we want to add the registry information and we click finish. Okay. Now, Just for interest sake, if you go to properties and you go to advanced system settings or environment variables, and you can see on path, we say edit over here, you can see CARM non-EMB version and then the bin folder. So that will add it to your path. So if it's not here, it won't work. How you can test this is simply by shift right click. That will give you a PowerShell window, and you can go to ARM no EMB, and then the bin file, no, wrong bin, this bin, and then GCC. So this name over here, so it's ARM non EMB, and notice that I'm directly in my C drive. I'm not in this path that is shown at the top. You just say here and you say -H, missing argument, but the fact of the matter is it's responding. So you see it says no input file, which is fine. What you don't want is something that outputs like the following, that it is not a recognized name. Then you need to add it manually to your path. So that's your ARM compiler installed. Now, next on the list was CMake. So I'll just install CMake over here. Yeah, that's fine. Next, I accept the license agreement. Do not add CMake to system path. Add CMake to system path for all users. Okay, so this is dependent on how you want to install it. I'm going to do it for all users since I'm actually the only user on this computer. So we click next. CMake tends to be fine if you have spaces in the... We'll just make sure and not allow spaces. So we'll install that directly to our C drive. You can place this wherever you want. You just don't want spaces in your path. You click next, install. Okay, so now we're finished. Now I just click finish here. Now we need to test again if it's functioning. We'll just pick the C drive again and just open a PowerShell here. Same method, shift right click and open PowerShell. Works in Windows 11 as well. Then we just want to say CMake. And then we get the help options and whatnot. So it's visible to the system path. Again, it will give you something in line of what this error is showing currently. If it's not installed correctly, then again, you need to add this bin path. So over here where you see the CMake, so wherever you installed CMake, so CMake /bin, and that's where your executable will live. Now the build, I'm going to skip the build tools because that takes a while. We are going to do Python next. So in our downloads, we get Python. Okay, so the version doesn't match up, but we'll try it. Maybe I should get the correct version. Okay, so this is 12.9, 10.4, no files for this release. Fantastic. Okay, so the Pi documentation needs updating, but the Windows support is lacking anyhow for the Pi Pico. Okay, so we're gonna YOLO it and try Python 12.3. Okay, so if this is your first time installing Python, we want to use the administrative and we want to add python.txt to our path. Customize installation, yes. And there's no spaces in this path, that's great. We don't need to install it for all users. Precompile standard library, done debugging symbol. Okay, that will automatically install if you do this in VS Code. Next we do is install. Now we're installing this. Okay, now once you've successfully installed Python, what you want to do is disable path length limits. I do this generally with every single Python install I do. This is a system-wide configuration and you need administrative access to do it. So we disable, great stuff, and we close. Again, we test if it's correctly installed. Doesn't matter where you open a PowerShell. And on Windows, you just type py and it will open a Python. It will show your version over here. And we can just exit. Now, if you want to run a specific version of Python, you just type in py-3.12.3. This is if you have multiple installs. Apparently not. There we go. Okay, so it's only the minor version that you need to type in, not the release version. So we exit. Okay, Python's correctly installed. Next one will be Git. So we do a yes there. So this is the more complex installation. Git can live in program files, that's fine. I don't mess with these settings usually, depending on what I'm doing. It's fine. My default editor is going to Notepad++. Okay, so from that installer you can quickly download Notepad++. Apparently this is required. It's not too a large download. I agree. That can live wherever. This is just the next install. Okay, we finish. Okay, Notepad. No updates now. Okay, launches happiness. Can Git see it? Let's try back and next. Okay, now it can see Notepad++. Let Git decide. You can do that. Use the bundled SSH. Use OpenSSL. Okay, this is the cuck one. Check out Windows style comment. Nope. Check out as is. You don't modify the end of line characters, because in Unix-based systems you have 1 backslash. In Windows you have 2 backslashes. So for compatibility's sake, do a checkout as is, and then you don't mess with the end of line characters. Next, we can use the default Git credentials manager. That's fine. It's fine. Install. Okay, I don't want to view the release notes. Finish. Okay, so we do it again and we test if the installation has been added properly to our path. We just say git-h and yeah, great, Git works. Okay, we have Git. Okay, now we're gonna do the monster install, which is the build tools for Visual Studio. Okay, and we can see all the settings that we need for installing for the RPi. So let's start that. Yes. Why on earth you need to download the Windows 10 SDK for this is beyond me. Look at that turtle size. Is this one day? Okay, I'll get back to you when it's ready, and apparently not 2 seconds later. Okay, so we want the desktop development with C++. And then let's just double check this in comparison to our settings over here. Okay, we got that tick, and then the version. Windows 11 SDK, C++, test tools, core features, nothing extra. Okay, now we just click install and install this ungodly huge SDK. Okay, so process is started. I'll get back to you when it's finished. Okay, so roughly 2 millennia later, it's finished installing. All the installations are up to date. Okay, definitely not uninstall this bloatware. But yeah, now we can close the Visual Studio installer down. Now we get to the fun bit. I prefer it to do it this way. You can put it in any folder as long as it doesn't have spaces in it. I'm going to make a new folder in my C drive called SDK. And then from that folder, I'm going to open a PowerShell window. You can see I'm in C SDK now. Now we're going to use Git to clone the SDK. Okay, we take PowerShell again. Apparently it didn't copy properly. Okay, copy, and we paste it there. So I right click on the PowerShell window to take whatever I pasted in, and it wrote it into the PowerShell buffer. So now we start cloning. Okay, next we go ls. So you can see there's the Pico SDK. And then we go cd p tab, and that brings up, you bastard. Then cdp, and that will, so I pressed p tab to autofill ls. Okay, so that's all the items. Then we do git init update submodules. Okay, I'll get back to you when this is done. Okay, you can see it's done when it returns you to the prompt. Okay, so let's go to the next step. We cd1 back, and then we copy the next clone commands. So these will be the examples. We can copy that. Okay, so this is now cloning all the examples for us. So if we ls now, you can see Pico examples folder in the directory. If you want to see it physically, here's it in the Windows. So now we can close down PowerShell. Now we need to test if everything builds. So we can go to our start menu, and as you can see here, developer command prompt. We're looking for this application, developer command prompt for VS 2022. This will open a CMD for this, and we want to cd into the backslash into SDK. Where do we want to be? Okay, we're going to do it a bit different to this. We are going to copy this variable, and then we're going to go to our PC. We're going to go to properties. We're going to go to advanced system settings, environment variables, and then we say a new environment variable, and the value is going to be our path to our Pi Pico SDK. I click OK. So we have a new environment variable, which is Pi Pico SDK. We just click OK there. We want to restart this. Echo, and what was that value? Pi Pico SDK. Pico underscore SDK underscore path. Echo Pico SDK score path. Just give me 2 seconds. Yeah, spot the Linux terminal user, eh? There we go. Okay, so you can see if you echo out this %Pico SDK path, you should get your path back to your SDK. So now this is permanently set. Okay, let's look further at the documentation. So this is effectively what the setx does. You just now don't need to do it every single time. Okay, then we go to, we want to be in Pico examples. So we go cd/SDK/Pico examples. Okay. Then we look at the next one. We want to say make dir build. Dir. So this gives me all the directories. And then we want to mk dir build. And then we want to run dir again. Let me just check. We do have a build folder now. Oh, we're going to have to do this the difficult way. Let's just move that here. We want to cd into build. And we want to say CMake -g. And our build type is going to be nmake, make files. I don't know if this is actually case sensitive. And then one directory back. So you can see here it found the compiler, found Python. Okay, then our configuration is done. And then all we want to run is nmake. Okay, and that's building everything. Okay, while that's building, it's going to take a while. We can just have a look see here. Build target. To produce the ELF bin and UF2 target, you can find these in the Hello World serial and Hello World USB directories inside your build directory. The UF2 binaries can be dragged and dropped directly onto your Raspberry Pi Pico board attached to your computer using USB. Okay, so anything we build, we want the UF2 binaries. So that's compiled specifically for the bootloader itself. Bin files and ELF files will most likely not include the bootloader. Okay, so you can see now here it's starting to run and build all the way. I'll get back to you as soon as this is done. So another 2 millennia later, we are done compiling. So this compiled every single example. Then we can go to our files. Then we want to go to our examples. We want to go to build. Now this is all the output files. So you can see here, here's a blink.bin, this, an elf file, a hex file, and a UF2 file. So this UF2 file is the one we're interested in. So now physically on the board, on the side, we can go to our PC, and then where our drive is mounted, we can drag and drop the blink UF2 into the Pi Pico. And now you can see on the side that the LED is blinking. Now, due to latency, it doesn't look like it's blinking at a set interval, but it is when you physically see it. Okay, so we have confirmed that everything works. Our entire toolchain works. Now we need to set up a separate project because this does not help us a lot. So I'm just going to make a new folder and call that source files. And we're going to create a new folder in that and call it Pico. And in here, we're going to say folder blink. And we go to our C drive, we go to our SDK again, we go to examples, and then we go to, let's say, the blinky one. And we copy the blink out into here. And then in here, Pico import sdk.cmake. We want that folder. Let me just double check here. Okay, now we're going to go to chapter 3, which is building blink. Okay, we've already done these steps. Let me just double check. I want to find out where this file is. Chapter 8, creating your own project. This is what we want to do. Okay, so we've already copied this folder on. Just double check everything here. Okay, so next thing we want is we want a code editor. So we say VS Code. It can be whatever you like. I prefer VS Code. Download the Windows one. Okay, you can install VS Code wherever you would like. Something I prefer is add open with code action to the Explorer menu. So I like to tick these two. Next, install. Okay, we don't need to launch VS Code now. Okay, we will no longer need this command prompt, but we need to set up our project. Okay. Looks like we're going to need this anyways. So now I have a context menu for Visual Studio Code. Let me just open Visual Studio Code here. Okay, we're not going to use the puts one. We can hold this as is. Pico. So we're just going to compile the Blink application. We copy the CMake minimum version. So this is how you set up a base project. And we copy all the rest of this contents over here. Add executable test.c and then create test.c. So we don't want to use this. We want to say this is main. No, that is blink. And then all our symlinks we want to change, and we want to remove these unwanted characters. Enable str UART. Don't believe we need these. This is the important one. We want to copy this import, Pico import, so the C source file. We want to go back to, and then we want to go to our source folder and paste that in. Okay. I can see the CMake file is here with all its defines. Okay. Now in our developer command prompt, so this is the same one we launched. So every time you're going to have to launch a new one, we go back, cd, 2 folders, and then is 2 folders, right? No, it's a third one, and then we go to source, or is it 2? One more back, okay. cd source, cd Pico, cd blink, there. Okay, then we open Visual Studio Code here, the code dot. Okay, so apparently I need to restart this terminal. cd/c cd source / cd Pico, cd blink, and then code dot. So that will open VS Code with all of the paths exported from this command prompt. And we can do terminal, new terminal, and we want a new command prompt. Okay, so this will be mkdir bold, cd bold, and then path is already set. Then we want to follow the Windows compile instructions again. We want to use this CMake. Then we want to use nmake. I'm going to edit this file that we blink once a second, just so that we can see the difference. Okay, now that's done building, we can see there's a blink UF2. Just going to rebuild this project. Okay, second round is always faster. So then we go to our build and we want the UFI blink. Now we got the rapid blink at the moment. So now currently the bootloader is not active. So what you need to do is you need to first unplug the Pico, hold in the little boot button over here while you plug it in, then hope it starts up one day. Okay, apparently that one didn't work. Holding down the boot button, and then you have to hold it for quite a bit. I'm forcing contact now, and apparently it's on the wrong drive. So it did open. So let me just attach it to the machine again. Okay, so it will come up again as a boot drive. Now we're gonna drag and drop the new blink. So this is the new blink, and that should blink only once a second. Okay, apparently that flash failed. So let's delete all the build files then and just make sure. Run our nmake. You can see it actually generate the files in the build folder as you go. Okay, 1 second. Well, I figured it out. I'm a moron. By default, I have autosave enabled on my main machine. I just needed to save the files. So we try nmake again. While we wait, I'll put the Pi Pico into bootloader. Okay. Now we just dropped the test file here. Okay, apparently it failed just by looking at the copy speed. Okay, that obviously failed. Attempt to mount the device again. And as you can see by the blinking LED, we have a slow blink finally. Okay, some quality of life stuff for VS Code. We are basically done here. But some quality of life, you want the extensions here. And then C, you want the extension pack for C++. This will install everything for C and anything related to C. You can see it installs the CMake Intelligence Debugger, CMake tools, etc. like that. And then if you press F1 and you say shell, we want to go to set terminal. So it's terminal, select default profile, then you can select whichever. For Pico development, command prompt is the default. Okay, so now when you create a new terminal, it will automatically open in a command prompt instead of PowerShell. Now we want to add a folder here, .vs code, and then on my GitHub, what you want to do is manipulate the URL and say just .github.com and then my profile, and then I have a build script here for the Pi Pico, specifically for VS Code. And in VS Code, you want to create a new folder, which is C properties. Apparently not. Is it configuration.json? Okay. So now we have this, and my VM appears to have crashed. Okay, so I've restored the VM. So I'm going to open this test folder again with VS Code without using the developer command prompt. And on my gist, I'm going to copy this configuration over. Okay, so you want to add the compiler path. Since we already have that in our global path, we can just add it like this. Pi Pico is already added to our environment path, so that will pick up automatically. Okay. Now we add a build script.bat file to the root of our project. Bullshit, it's a very valid name. Right? Next document. Okay, I need to change this folder. Add the extension of known file types. We want to disable that. And this will be build script.bat. Yes, I want to change it. Okay, now back to VS Code. I think this is an administrative issue. We want to paste this in. This will call the second input parameter and just run our build scripts. And then we want to create fortunately I have to do it like this. I need to set the admin permissions on this VM correctly for me to create files apparently. New text document and just copy. Control-Shift-V, and that apparently also doesn't work. So let's just get that, see if I can rename it over here. Okay, it's happy with settings.json over there. Okay, we want to add our settings over here. Now we want to find out what this path is. So how we do that is we go developer command prompt and we open file location. We open properties on it, and then we want copy this path out of the target, right? And then we want to control F all of these. We want to replace these with forward slashes. Okay. Now we got our path to our developer command prompt, and we want to add a second. Actually, we want to do this. Okay, apparently you can't do that. Backslash, and then over here also quotation mark backslash, because this path has spaces in it. You need to put this into quotes, otherwise it won't work. Then we want to create a task.json, create a new text file. Yes. Okay, we got a task.json now. Okay, we just copy this over. And we need to save all of these. Okay, so what the C++ properties does, it allows you to use the IntelliSense. So it will take you automatically to the SDK points. You can see here it takes you to time.h and so on and so forth. Task does, okay, so settings just gives you the path to the developer command prompt. And then we have the batch script in our task. When we do a build, pass in the path to the developer command prompt. And now what our batch script does, calls that developer command prompt and adds all the information to our system path. And we've changed the default terminal to command line that will automatically launch. So if we press F1 and we say task and run, we say run task. And we have two, we have build and we have clean. You can see here it automatically imported the command prompt for us. And that built the target. If we want to clean, we'd say F1, run task, clean. That deletes the entire output. We go again. We say build, and you can see it building from scratch again. And that's how to install the CSDK for a Pi Pico on Windows. Like, share, comment, and subscribe is always appreciated. Thank you. Have a nice day.